is Billy Bob, and I'm going to teach you about combinations and permutations today.
Huh?
You see, class, in some cases involving choices, the order in which the choices are made is very important. Imagine if a group of 12 wishes to choose a president, a vice president, and a treasurer. In this case, the order is important. For example, having person A as president, B as vice president, and C as treasurer is different from B, A, C, president, vice president, treasurer, respectively. It's different. Now imagine if a group of 12 wishes to choose 3 council members of equal rank. In this case, the order does not matter. For example, a council that consists of persons A, B, C is the same as a council that consists of people B, A, C. They are the same. Now, going back to the first example where the order was important, each selection is called a permutation. Permutations are denoted as NPR, where N is the number of total selections, and R is the number of things chosen from N. To show that we're choosing a president, a vice president, and a treasurer from a group of 12 people, we write 12P3. Obviously, N is always greater or equal to R, which is always greater or equal to 0.
What?
To calculate the number of ways R could be chosen from N, we use this equation. The exclamation mark means factorial, whereby you multiply all positive integers less or equal to N. N factorial equals N times N minus 1 times N minus 2, and so on. To show that we're choosing 3 people from a group of 12, we denote it as this. 12 factorial over 12 minus 3 factorial. This is expanded as this, where you cross out the bottom from the top that equals together, and you come out with 12 times 11 times 10. This equals 1,320. This means that there are 1,320 ways to choose a president, a vice president, and a treasurer from a group of 12 people. Taking you way back to the problem where the order did not matter, each selection is called a combination. Combinations can be denoted as NCR. The equation for combinations is N factorial over N minus R factorial times R factorial. Just like the second problem, where a group of 12 were trying to choose 3 council members of equal rank, the 12 equals the N and the 3 equals the R. This is written as 12 factorial over 12 minus 3 factorial times 3 factorial. This means 12 times 11 times 10 times 9 factorial over 9 factorial times 3 factorial. We cross out the 9 factorials to get 1,320 over 6. This means that there are 220 ways of choosing 3 council members of equal rank from a group of 12 people. Hey y'all, what's up? I'm Ray John Smith. And don't tell Mr. Walker, but I'm going to teach you shortcuts on how to solve permutation and combination problems. First, you press the math button on your calculator. Then you go all the way right to the probability section. You see the buttons NPR and NCR. All you have to do is enter the selection number for the N and the choice number for the R, and voila, it does the equation for you. As you can see here, it does this and it gives you the result immediately. Permutations and combinations, they're both the same. NCR, just enter the selection number for N, 3 is the choice number, and voila, it gives you the result. Always remember, the permutations is always greater than the combinations. This is because of the extra R factorial in the combinations equation. This extra R factorial eliminates the double count and ensures that the ABC is equal to the BAC, just like in the examples.
In a perfect world, all the geeks get the girl.